Hello, this is your first video on solving systems of linear equations. The first learning target we're going to look at is solving a system of linear equations by graphing, and the other one we're going to touch on is identifying that parallel lines have no solution. So a system of linear equations is a set of two or more linear equations containing two or more variables. In this case, we usually work with x and y. And a solution to a system of linear equations is an ordered pair that satisfies each equation in the system. So steps to solve. Step 1 is to graph the lines as you normally would. Step 2 is look for where the two lines cross. And step 3 is the place where the two lines cross is the solution. Just to note that we write the solution as an ordered pair xy. That's kind of our last step every single time. So let's look at some examples. We have two equations here. They're both in slope-intercept form. So you have y equals 3x minus 1 and y equals negative 2x plus 4. Step 1 just tells us to graph the lines as we normally would. So if I'm going to start with this equation, I'm going to start my y-intercept, which is negative 1. So I'll put a dot there. And then I'm going to use my slope, which in this case my slope is 3, to plot some more points. So I'm going to go up 3 and over 1. When we're solving systems of linear equations, it's important that your lines are straight and accurate. So I always encourage students to draw more points instead of less. Now we're going to graph the second one. I'll do that one in blue. Y-intercept is 4. So I'll put my first point at there. Then my slope is negative 2, so down 2 over 1. Some of you can see we just crossed one of our points already. We crossed that pink one right there. So this point is our solution. That ordered pair works in both equations. So my solution would be 1, 2. Alright, so in example 2, we have two equations again. The first one's in slope-intercept form. Our slope is a half and our y-intercept is negative 3. Our second equation's in point-slope form, so we're going to want to convert that before we graph it. I'm going to graph the first one just to get started. So y-intercept is negative 3, my slope is 1/2. So I'm going up 1 and over 2. If I want to go to the left, I'm going to go down 1 and back 2. If you guys are doing this on paper, it's kind of nice because you can use a ruler or some sort of straight edge to kind of get your line drawn. For this one, let's distribute that negative 4. So we have negative 4x minus 4, and I'm going to add 1. So y is equal to negative 4x plus 3. Now I can graph this one, see where it matches up. That should have been a negative 3, excuse me. Let's fix that. Okay, so now my y-intercept is negative 3, which some of you are like, wait a second, that's already on top of a point. That is our solution then. Just to kind of complete the graph, I'm going to draw in another point so we know where our line is going. My line has a negative slope, it should go down. That first point though right here was where my pink and blue crossed, or where they touched. So that is my solution. So x there is 0. And my y is, it looks like negative 3. So that is my solution. Okay, in this case we have two equations, y is equal to 5, and then our second equation is in standard form, so it says negative 2x plus 2y is equal to 4. I'm going to do this first equation. Hopefully, I want some of you guys to stop and think, or all of you to stop and think, what the graph of y equals 5 should look like. Is that a horizontal line or is it a vertical line? Well, if I have just y is equal to 5, I know I have a line with a slope of 0, so it is a horizontal line. So all I do is find 5 on the y-axis. So that's going to be up here. And then my line is going to be horizontal, so it's going to go right through 5 all the way across. Now again for my second equation, let's solve for y. Again, I encourage you guys to show your work here to avoid making silly mistakes. So 4 plus 2x and divide by 2. So this one is y is equal to 2 plus 1x. If you don't like writing the 1 in front of the x, that's fine. y-intercept is 2, my slope is 1, so up 1 over 1, all the way through. I see a point where my lines cross, that is my solution. So in this case, my solution is going to be 3 for my x and 5 for my y. And that one is done. Alright, let's look at example 4. This is again first equations in slope-intercept form. Some of you guys notice that our b value, our y-intercept, is missing. That must mean that there's a plus 0 there, our y-intercept 0. So I'm going to put the first point there. My slope is 2/3, so up 2 over 3. To go to the left, I'll go down 2 back 3. And then draw my line as straight as I can on my iPad. And for the second one, let's solve for y. So I'll subtract 2x. Negative 3y is equal to 9 minus 2x, and divide by negative 3. So y is equal to negative 3 plus 2/3 x. So I'm going to start at negative 3. I'm going to go up to, over 3, back down to back 3. Some of you guys are probably noticing something interesting here. My lines don't cross, and they don't seem to be getting any closer. Some of you maybe already noticed this, but if we look at our slopes, so in our first equation, the slope is 2/3. In our second equation, our slope is 2/3. If the slopes are the same, then our lines are parallel, which means they will never cross. So that's the case every time. If the slope's the same, they're parallel, and then there is no solution. So if you were to look at two equations, so in this case, in this step here, if we had noticed that the slopes were the same right away, we wouldn't have to graph them to prove they were parallel. We could just state that the slopes were the same, so we knew they wouldn't cross. And of course, let's do a word problem example. So it says Bowl-O-Rama charges $2.50 per game plus $2 for shoe rental, and Bowling Pins charges $2 per game plus $4 for shoe rental. How many games do you have to play for the cost to bowl to be the same at both places? And what is that cost? So I'm going to use pink for Bowl-O-Rama. So y is equal to, it's $2.50 per game. So for every game, so multiplied by x, plus the initial $2. Bowling Pins only charges $2 per game, but they charge $4 for their shoes. So we're just going to graph these as usual. You'll notice I didn't do a full graph. We're just using the first quadrant here because we're not going to have negative games that we play. So if I do Bowling Pins first in blue, we're going to start at 4, and my slope is a positive 2. So I'm going to go up 2 over 1. Not really sure how far I have to go up yet, so I'm just drawing my points in. For you guys on your paper, you kind of notice this is a steeper slope. It's helpful to use a ruler or a straight edge to help you out. Now for Bowl-O-Rama, it starts at $2, and then I have to go up 2.5 and over 1. So instead of doing that, because it's kind of hard to do, so my slope is 2.50 over 1. I can say that's the same thing as saying 5 over 2 to make it easier to graph. So I'm going to go up 1, 2, 3, 4, 5 over 2. So you'll notice that it's close already, but not quite touching. Up 5 over 2. If I hadn't seen where they crossed, so now when I did it that way, I could see that they crossed right here. If they hadn't, I would have gone back and added more points in on my pink line just to see where they crossed. So in this case, it looks like they had to play 4 games. And let's try to find our cost here. So and it would be $12 total. So graphing is a great way to solve a system of linear equations. A lot of students like it because you guys are comfortable with graphing. It's something you're good at. Sometimes though our solutions aren't whole numbers. So like in this case, our x was 4, it's a whole number. Our y was the $12, which is also a whole number. It doesn't always work out that nicely, so we have to have other strategies that we can use to help us. So in the other videos, we'll review solving by substitution and solving using elimination. After this, you should do your practice and then move on to the next video when you are ready. Thanks!